All right, we're going to learn about similarity in right triangles. We begin with a right triangle. You can tell that the right angle indicates that. And I'm going to drop an altitude. We know that an altitude means it's a right angle. Now, when this happens, we create actually three triangles. Does everyone see my blue triangle? Notice that by introducing this right angle, I've introduced a second triangle, which we're going to say is purple, which is also a right triangle. And a third right triangle, which is red. I'm going to begin by reorienting all three of these triangles so that they're in the same direction. Here's my blue triangle. Here's my purple triangle. And here's my red triangle. Now, in order to swing these around and reposition them, I have to keep track of where I began. Looking at your blue triangle, this was our right angle, and I'm going to call this angle, angle A, for no apparent reason. And this angle, angle B. But now you see when I swing this over, this is my angle B, and this is my angle A. Now let's look at the purple triangle. I've already got a right angle in it. I've already got an angle B in it from left over from the blue. So if it shares a right angle and an angle B, then these two triangles are similar by angle-angle similarity. In addition, with my third triangle, my red one, if A already exists and a right angle already exists, then it's similar to my first triangle by similarity. And because these third angles must be the same, if two angles in one triangle are congruent to two angles in another, the third angle must also be the same. I can say that all three of these triangles are similar by angle-angle similarity. We can use this information to build proportions, to solve problems. So I'm going to begin by labeling my triangle A, B, C. And I'll put in a little x, a little y, and a little h there. And we're going to create the proportions based on these similar triangles. I'll start with my blue triangle. Side C is opposite my blue right angle. Side C is opposite my blue right angle. Side B is opposite angle A. It's confusing. And side A is opposite angle B. Now let's go to our purple triangle. Opposite angle B in my purple triangle is H. Opposite angle A, this was an A up here, this was B up here, so all three triangles have A, B, right, A, B, right, A, B, right. Opposite A is Y. And opposite 90, my hypotenuse is B. Lastly, in my red triangle, opposite angle A is H. Opposite angle B is X. And opposite my right angle is A. If these three triangles are now oriented in the same way to show corresponding locations, and they're all similar, then I can set up proportions. Our first proportion comes from this to say that H is to X as Y is to H. Our second proportion is A is to C as X is to A. And our third proportion is B is to Y. Actually, let's go. B is to C as Y is to B. Now you may ask, what good is all this stuff? What it allows us to do is solve problems with a right triangle, dropping an altitude. If I wish to find out this value, and this value, I can set up the proportions. This side, A, is to the leg closest to it as this whole side is to A. It comes from this relationship here. A is to the whole side as this little part is to A. A is to the whole side as the little part is to A. Now that lets me use cross multiplication to solve. A is equal to 15. I could also find B. B is to the side next to it as the whole hypotenuse is to B. B times B is equal to 16 times 25. B squared is equal to 16 times 25. B is equal to the square root of that, which I'm going to factor and solve. You could multiply it out and solve it that way, but I find this faster. And the last one is we can find this x value by recognizing that x makes a relationship with a two-part split. X is to 9, S16 is to x. X squared equals 9 times 16. X equals square root of 3 times 3 times 4 times 4. X is equal to 12. Turns out, in each of these cases where we end up with the side squared equals the product of the other two, this is a special relationship for us. It's a relationship called the geometric mean. Remember the arithmetic mean? Arithmetic? That says that if I have two numbers on a number line, that I'm looking for some value here in the middle, such that when I add a number, and then add that number again, this will be exactly in the middle. This is what we call the average. The way we find it is we say, add these two together and divide by 2, and this is the exact point where I can go up 3.5 in this case, and up another 3.5 in this case, to take a two-stepper from here to here. This is called the arithmetic mean. And this is what we know as average. The geometric mean is a similar concept in the sense that we're looking at two numbers on a number line, and we're saying, what is it that is halfway between these? But instead of looking for a number that adds evenly, we're looking for a way to multiply this times something, and then multiply it again to get to here. So the geometric mean of the numbers 5 and 20 means you take those two numbers and multiply them together, and then square root. In other words, 5 times 2 is equal to 10. 10 times 2 is equal to 20. The geometric mean can be expressed as what we just saw in similar triangles. These two products multiply together, make these two products multiply together such that A is the square root of x and 1.